Welcome to lesson 2.4. This is an extension lesson. In this lesson, we're going to talk about the shortest distance between a point and a line. So first, let's consider 2 points, P and Q. P is at the ordered pair x1, y1, and Q is at the ordered pair x2, y2. Now, we've already done this back in lesson 1.6. So what we do is we connect the 2 points together, P and Q, and we call this distance d. And we figured out that if d is the distance, then the formula for distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. But we took another perspective too. We noticed that if we made a right triangle and then found the lengths, we could use the Pythagorean theorem. So if I let A be the x2 minus the x1, and if I let B equal the y2 minus the y1, then I can use the formula a squared plus b squared equals d squared. Yeah, I know that's supposed to be a c, but remember, the letter doesn't really matter, and d makes more sense for distance, right, between p and q. So in this case, d squared is equal to a squared plus b squared, and I still get that d is the square root of a squared plus b squared. So that goes all the way back to lesson 1.6. Okay, so what I want to do now is I want to take the following situation. I've got a line and a point called P. And P is located at -2, 5. So starting at the origin, left 2, 1, 2, up 1, 2, 3, 4, 5. And there's the point P. I want to find the shortest distance from P to the line, y equals mx plus b. In the first part of 2.4, the last lesson, we learned that the shortest distance between a point, right here, and a line is the perpendicular. So the job now is to figure out, okay, can I get the equation of this line? The answer is yes. I'm going to show you how to do that. Then what is the slope of that line? We're going to use a little fact that the perpendicular slope, which is what we're going to find, is the negative reciprocal of the slope of this line. In other words, if the product of two slopes is -1, then the lines must be perpendicular. So that's what we're going to do first. Okay, so I've got a little bit of work to do to try and show you this. First of all, notice that the line goes through -3 on the y-axis. That's the y-intercept right there at -3. So that means that B, recording this at the same exact time is probably not the easiest thing in the world. All right, B is equal to -3. Now, can I find the slope of the line? Yes, I can find the slope of the line. So here's what I do. Start here, go up, 1, 2, 3, run over, 1, 2, 1, 2, 3, 1, 2. And so that I notice that the rise is 3 and the run is 2. So the slope is 3/2. All right. So the equation of the line is y equals 3/2 x minus 3. Okay, now I've got the equation of the line. Well, what that means is that now that I know the slope of this line right here, I can now find the perpendicular slope. So the question is, what mystery number multiplies by 3/2 to give me -1? So 3/2 times what mystery number is -1? Well, the answer to the mystery number is -2/3. So that means that the slope that joins point P perpendicular to this line is -2/3. So now here's what I'm going to do. I'm going to go ahead and I'm going to connect P, and I'm going to go down 2, right 3, down 2, right 3, and I'm just going to keep doing that. So let's go ahead and do that. Now I've connected the two lines. And this line here is now perpendicular to that line there. The first line has a slope of 3 over 2. And the second line has a slope of negative 2 over 3. Now, this is where the lines meet, right here. So, I've got to figure out where that point is, and let's give it a name. So let's call it Q. I've now named the point where the two lines meet. I've now named the point where the two lines meet as Q. So now what I want to do is I want to figure out where that point is. So let me show you how to figure out where that point is. The very first thing I had to do was create an equation for the line. I know that P goes through negative 2, 5. And I know the slope is negative 2/3. So I use the point slope form of the equation. Y minus y1, that's the 5, equals m times x minus x1. That's the negative 2 there. Use the distributive property. So negative 2 times the x, negative 2/3 times x is negative 2/3 x. Negative 2/3 times 2 is negative 4/3. Now it's time to add 5 to the other side of the equation. This finally gives me the equation y equals negative 2/3 x plus 11/3. And now what I have is I have the equation of the line that is perpendicular to the original line. So it's the equation of this line here. All right, well, I still haven't figured out where Q is yet. So that's what we're going to do next. So let me show you how to find Q. Now the really important thing at this point is that I have both equations. I have y equals negative 2/3 x plus 11/3. That's the perpendicular line. I have y equals 3/2 x minus 3. That's the original line. So if y is equal to both of these, I'm going to use the substitution property of equality and set them equal to each other. Now, to make my life easy so that when I deal with fractions, I notice that my denominators are 2 and 3. And if I can get rid of denominators, life becomes way easier. So I use a little concept known as the LCM, the least common multiple. The least common multiple is the number, the smallest number, that both 2 and 3 divide into together nicely. And that number is 6. So what I ended up doing was I multiplied through the entire equation by 6 using the multiplication property of equality. 3/2 times 6 is 9. Negative 3 times 6 is negative 18. Negative 2/3 times 6 is negative 4, and 11/3 times 6 is 22. Now the fractions are gone. Add 4x to the other side, get 13x. Add 18 to the other side, get 40. Divide by 13. I now know the x value where they meet. X is 40 over 13. Now it's time to find the y value where they meet. Since I'm looking for the place where the two lines meet, I can now pick any equation of my choosing and take the 40 over 13 and plug them into either the first or the second. I chose the second. So what I did was I plugged 40 over 13 into the equation, y equals 3/2 x minus 3. I multiplied it out, and I get 60 over 13 minus 3. I turn 3 into 39 over 13 to get a common denominator. 60 minus 39 is 21, so the y value is 21/13. And now I know where point Q is located. Point Q is located at the ordered pair of 40/13, 21/13. Now there's only one step left, and that's to actually calculate the distance. Okay, I have the distance formula. D is the square root of x2 minus x1 squared plus y2 minus y1 squared. I put in the numbers I know. P is located at negative 2, 5. Q is located at 40/13, 21/13. So, formula becomes negative 2 minus 40/13 squared plus 5 minus 21/13 squared. Now if you can get this far, I'm going to let you use your calculator for the rest. So I'm going to show you how to do that next. And it's pretty easy now to just type that into our calculator and we'll get the approximate distance. I am going to want the distance to the nearest hundredth. That's 2 spaces after the decimal. So if this is a number point, so 2 spaces after the decimal to the nearest hundredth. Okay, let me show you now how to plug that in your calculator and get the answer. And so here we go, ready to calculate the distance. So here's what I do. I first begin by taking the square root, and I need parentheses. So I begin parentheses, -2 minus 40 13ths. And the way that I do that is I say 40 divided by 13. Close the parentheses, and let's raise this now to the second power. Now what I do is I say plus a parenthesis, and this becomes 5 minus 21 divided by 13, so that's 21 13ths. And let's raise that to the second power. So if you have a TI-84, it's as simple as this, typing in each expression. Hit enter, and that means that the distance between the 2 points is roughly 6.10. 0 is in the hundredths place, and the 1 in the thousandths place is not enough to round up that 0. So the distance basically roughly between points P and Q is 6.1. Now what if you don't have a TI-84? Well, what you'll probably have to do is this. You'll have to calculate one thing at a time. So first take -2 minus 40 divided by 13, and you calculate that. Then what you'll end up doing is you'll end up squaring your answer. Even if you don't have a TI-84, usually calculators have something on it called ANS that stands for answer. So basically what you'll do is you'll use your second key and then you'll square that answer right there. Hit enter, and so that's the first part squared. Now let's calculate the second part. 5 minus 21 divided by 13. That's the second part, but I've got to square that. Since 3.38461538 was the very last thing calculated in my calculator, that's now stored in the answer variable. So I go second answer, square key, and now I have 11.4556213. I've got to add this number to this number. So my calculator makes it easy enough that I can just scroll up to the last, to what I want, type it in, and then say plus that number there. You may have to type them all out. There we go. The last thing now to do is to take the square root, and since this number is now stored in the answer variable, all I have to do is say square root of answer, and I hit enter, and there it is. There's my 6.1. And that is how you find the distance between a point and a line. All right, let me just give you a summary of the steps that we took, and that will be the end of the lesson.